All right, hey, welcome everyone to the Cox Analytics Summit. I'm a little biased. Want to welcome you all. We're going, I believe, 4 years, and every year we're doing something a little different. The structure of the day is a little different, and this year I think we have a really good format in the sense of one of the feedback that we received was not really understanding how Cox Analytics looks across all the organizations. And so this year what we're trying to do is bring up key leaders of different areas, specifically in analytics and data science, to talk about their areas, and as well as then have someone within their team present content that has been built by those teams. So in the case of most of the speakers today, you'll be seeing exactly what they're doing within those different organizations. But to go off a little script a bit, I just wanted to check in the audience, how many people today are programming in R? With raise of hands. All right, how many in SAS? How about Python? Are there some of you that are programming in multiple languages? Great. I noticed tension over the past few years as the programming languages became very polarized, but now I found that folks are starting to really bring that code together and use the best tools to answer the business question. But I was wondering maybe if we get some of the R folks up in Python and SAS and maybe mixed tables, a group hug or something, it would be probably good to lessen that tension. But I think all of them provide a ton of value. So I'm going to introduce Spencer. He is the partner in in today's event, and he's been basically running this for the past 4 years. So I really appreciate him letting me be a part of it this year, and look forward to a great event.
Sean, thanks a lot. First off, thanks for everybody being here. My name is Spencer Taft, and I'm at Cox Enterprises, responsible for analytics and data. And so one of the goals and things that I like to do is connect people. So we've been doing this, like Sean said, for 4 years. And really the goal is to get people together to share ideas around the advanced analytics space specifically. So the area is so big. I think this year we've got a webcast. So we're broadcasting live out into California and other parts of Cox, so that's exciting. And without further ado, I'm going to go ahead and get this thing started and introduce our keynote speaker. I'm holding his book, which is The Analytics Revolution. He currently works for a company that is called the International Analytics Institution. And he is working with Tom Davenport. So everybody probably has heard Tom Davenport, but I think you're going to start to hear more and more about Bill Franks. So without further ado, this is Bill Franks. He's going to talk about the AI and cutting through the hype.
All right, well, thanks, Spencer. What I'm going to do today is walk you through really what's one of the hottest topics, if not the hottest topic in analytics today, which is AI. I think the last time I saw so much excitement / buzz around something was big data about 7 years ago. What I want to walk you through is just some thoughts on what is it, where are people interpreting it properly, where are people a little over exuberant, and what are some of the strengths and pitfalls you should be aware of. There we go. So why is now the time for AI? This is one thing that often gets brought up. You know, AI, there was a burst around AI multiple times over the last couple of decades. Why is now it actually happening? First is the computing power. We'll come back to this, but it's not just that simultaneously has the cost of the computing come down, but obviously the power of the computing that is available is massively higher than it has been in the past. And we sort of hit a critical mass point where the availability of computing power and the cost of that are both now in the range that makes this a completely feasible activity versus a few years ago where the cost would have run you totally out of range. Then there's the power of the algorithms. There's been so much research done and evolution of the underlying algorithms behind AI. There's a bunch of different variations that you can utilize. Each of them have not only been continuously getting updated, but they're getting packaged and made available for folks like you in the room to actually make use of. I know a few years ago, a gentleman I know here in Atlanta was into deep learning back when nobody had really heard of it. In fact, he's the person who introduced me to it. And when he was describing what he had to go through to actually make it work, it was incredibly painful. And he mentioned that there, at the time there were very few people anywhere that could actually do it outside of a research or academic environment. That's now becoming democratized. And then the data availability, the type of data that's often used for AI in practice, like language for text processing or images and so forth, isn't the type of data that was necessarily captured and stored even a few years ago by organizations, let alone in a way that was prepared and available for analysis. So all that comes together. The one fact I remember seeing that really brought this point home is that somebody from, I think it was somebody from Google that mentioned that if you went 10 years ago, it would have taken months to do some of the processing for some of these models today. And again, at a much higher cost for those months of processing. An hour 5 years ago, and now it can be under a minute. So you've gone from many months down to just minutes. And the cost of those minutes is a fraction of every minute of what the months was. So that all adds up to a lot of opportunity. Now, one thing that surprises me is this often stated concept that somehow AI is completely different from analytics, and that this is this new thing that is not part of analytics, but an entirely new discipline. And I think that's a little short-sighted, and I'll explain why. I think this is my blog maybe last month or month before. If you think about in practice, how are people using AI? It sounds a heck of a lot like the exact process and reasons that you use analytics. So for example, if I want to predict which of you were going to respond to an offer, I have to go collect data. That includes people who did and didn't respond to an offer. I have to let a model train on that to identify what traits in the underlying data are associated with that offer. And then I have a scoring routine where I can show you a new person with their data, and it'll come out with the probability that they will respond to that offer. Well, AI, let's take image recognition. You have to go get a bunch of images of a cat and not a cat. You kind of have to tag them and prepare them, and you send it through an algorithm, and it's going to look for what are the traits in these data sets that differentiate a cat from not a cat. Once I have the model trained, I feed it a new image, and it spits out, here's the probability that this is a cat. Very, very, very similar. And so the point is that analytics is absolutely encompassing of AI. AI is certainly a new type, a new option in your toolkit, but it is analytics. AI also happens to be associated pretty heavily with the trend, and it was the theme of my book around the industrialization or operationalizing of analytics, where you've got to take them and embed them and automate them and make them just happen as part of a process. So with general analytics, one of the main points that's happened, everyone's familiar on websites now. When you click, they're going to do some processing very rapidly to optimize offers. A lot of the AI applications today are operationalized from the get-go. So when you're talking about text, when you're using Siri or Alexa, you make a comment, it immediately gets analyzed, it immediately identifies what it thinks you've asked, and then compiles an answer. Or in image recognition, same thing. I upload a picture, it might immediately then tag who's in that photo with me in an automated way. So it piggybacks on the back of that exact same type of process. There's a lot of terminology, as with anything, and you can go look these up. My point here is that you need to wade through it a little bit, and you have to be prepared to be a little confused. So my favorite dilemma with AI that actually took me, I'm not kidding you, a couple weeks to figure this out, because I kept hearing these acronyms, and I heard someone talk about an RNN, and then I heard someone else talk about an RNN, and they didn't really sound exactly the same. So I went and read an article one day on an RNN, came away, okay, now I got it. But then a little later, I read another article on an RNN, and I'm like, wait a minute, now I'm confused. Why? Because there's two RNNs in the lingo of AI. There's a recurrent neural network and a recursive neural network, and they both go by RNN. So there's an example where I think that's, somehow we gotta clean up some of the terminology, but you need to wade yourself through that and then make sure that you know what people are talking about. when we talk about the technology, one of the things that's really enabling this are these graphics processing units. And so, they were originally developed to render graphics for video games, high power graphics very quickly. Well, they have a lot of processing power, and if you go out and look around what's happening in AI today, most of the big applications of it are making use of GPUs in some way. And these are now available if you're on any of the cloud providers, you can actually rent the GPU processing. And the key here is the GPUs solve a slightly different problem. When you think about big data and having to process a lot of data, there's a lot of systems that are engineered to allow massive amounts of data, maybe terabytes, petabytes of data to flow through to do an analysis. The GPUs are a slightly different focus. They can't handle directly such a massive amount of data. They can handle a reasonable amount of data, but they can do a massive amount of computations, which is exactly what a lot of these AI algorithms need. So for a GPU, you may be passing many, many images through the process. And so in aggregate, there's a lot of data, but the amount being processed at any point in time is, by today's standards, manageable. It's the massive iterations that are what really drive the power of those GPUs. They allow you, back to that, computation is really the key today. Very inexpensive, very many iterations, very quickly. Open source has been really a huge factor in general, in technology in general, but in analytics specifically as well. But with AI, it's even more pronounced. Even the commercial companies that are getting into AI, like Microsoft, they have various toolkits that they're open sourcing around it. And so if you go to some of the AI shows and you look at what are people doing, there's actually not very much of a market's activity on what I'll call the proprietary pay-for-the-algorithm AI. The algorithms are primarily just there and available and being open sourced, even if commercial companies are involved. Where the money is being made today is the wrappers that get put around the fundamental algorithms, where people are adding either a process or industry-specific wrapper that uses those algorithms for a set purpose. And I think this is a trend that's continuing. Even with the question about the R, Python, and SAS a little bit ago, there was a pretty good distribution of each. But I don't know, even 5 to 6, 7 years ago, there probably would have been almost 100% of hands with a commercial tool like SAS or SPSS, and very few that would have been R and Python. With the new spaces like AI that are coming out, I think we're starting from the open source as the default. One example of how fast this is changing, by the way, this was amazing to me. So a gentleman at a conference was mentioning about, in the old days in the academic world, as research was done, people were very protective. So if I had just completed research and had a cutting-edge result, I would then go through what could be many quarters or even years to get it peer-reviewed and published. And I wouldn't share anything until it was published, because I needed to protect my IP and all, and that actually slowed the progress. Today, people are, as soon as they have a result, publishing their tentative findings out publicly while they go get it peer-reviewed. And the gentleman mentioned an example where a new AI piece of research came out, and within 90 days, they saw one of the commercial companies actually embed that new finding into their product. So you're talking 90 days from a brand new idea that had never been mentioned before on paper to actually available for you to purchase. I mean, that is just massively faster than anything we've seen in the past. And so this is why this space is going to continue to just full speed ahead, rapidly change. Where we come in contact with it probably most today in practice, the average American at least, would be in the natural language processing with things like like Siri and Alexa. There's also a lot of language processing being used in different areas. So if you haven't read about it, you can go research. There's actually news organizations now using natural language processing to automatically create articles on things that are fairly standard amount of things, like a sporting event. Typically, you find out who scored in what order on what type of play or what inning, et cetera. Or financial reports come out. In fact, they're legally have certain formats for some of these government reported financial results. So now they can apply these algorithms on top, extract the relevant info, and actually put together an article that sounds pretty good. And it's very cheap to do. And so you've probably read articles even on news feeds or in the paper that came from AI. So let's talk about one of the biggest mistakes that people make around AI in terms of what they think it is. So there's this talk about, are the computers going to be smarter than us and we have, a Terminator type situation anytime soon? The answer is no. In fact, there's a huge misunderstanding about generalized versus specific intelligence. And so to illustrate this, I'd say, is AI more like Einstein or more like a savant? The common hype is that AI is Einstein. It's brilliant. It's all-encompassing. It knows so many things. And it is true that there are instances of AI that know many different things. Some AI plays Go. Some AI answers your question on Siri. Some AI tags your face. But it's actually not like Einstein at all. In fact, AI at base is very, very focused. You have to train it on every specific thing that you need it to do. And if I get my algorithm incredibly good at identifying cat pictures, it still doesn't know a single thing about identifying dogs, let alone how to translate language. And so you have to understand that it's very powerful when you train it and retrain it on additional and additional problems, but it's not this generalized intelligence. And the best example of that I've heard is, if you were to show anyone in this room a picture of some new plant or animal that you've never seen before, one picture, and then we showed you 100 other pictures, you could pretty much go through and with a high level of accuracy pick out that animal or plant in those pictures, even though you've only seen one example for 10 seconds. AI, that's not going to be the case. Image recognition, you'd have to go and do an entire training through massive numbers of iterations with a whole lot of images that were and were not that new item before it could learn. And so this is something to understand around the generalizability. Much of what it's doing today, it's very specific. Very smart, but very, very specific. And part of it is that it actually starts dumb. For as much as you hear, you all heard about if you have enough monkeys hitting enough typewriters, eventually they luck their way into writing War and Peace, character by character. And that's true statistically. Back to the processing power. What actually happens in these AI routines, like let's take deep learning, it literally starts from random. It literally sits there, just sees a set of pixels, and then it says, okay, what if I tested whether these pixels help me differentiate whether this is or isn't a cat, for example. What about these? What about these? It just tries random things again and again and again and again and again, and over millions and millions of iterations, it actually learns, surprisingly enough. And eventually, it'll come out and tell you, yeah, this is a cat. But it starts from a very, very brute force perspective, and that's why the computing power was so critical. As smart as it gets, it's actually one of the, in my mind, in some ways, some of the most unintelligent algorithms at the very base level, because you basically let it try random things and monitor how those random things are working out and tune itself until it guides to the right answer. And so when you put these together, it can actually appear smarter than it is. So a gentleman from university was talking about a process they had built, and he had a similar picture of this. He said, we got it to the point it would identify this is a tennis game, and it looks like there's two females playing tennis, and one of them's wearing a tennis skirt, and one of them has on a cap or a visor, and they had trained how to identify all these various things. But here's where the nuance came in. So how many people think that she's about to hit a tennis ball right here, based on the picture? So people have to vote. Can I see? Right? Okay. And guess what? When you ask their algorithm, when you ask their process, is she about to hit the ball? The answer comes back yes. But let me ask you another question. How many people think that she just hit the tennis ball? Okay. A lot of people just is. Guess what? If you ask the algorithm, it's going to come back and it would say yes, she's just about to hit the tennis ball. Well, in reality, she either just hit it or is just about to hit it. She can't be doing both at the same time. And if we were thinking about it, we would probably say, if you had time to think, you'd go, well, wait a minute. Clearly, she may be about to hit it, but she might have just hit it. We need more information or more context. And so the point is, the AI is very, very smart within the context in which it was trained. And this is an example where it can give you answers that are actually logically impossible to both be true, but it doesn't have the knowledge with which to do that. And so over time, you either have to train it on that context or program it to identify areas where it has to ask for more information or identify that it doesn't have complete information and just say, I can't answer this question. You would have to provide me more information. And so at the end of all of these, you still end up with a probability. And this is something I find interesting. When you talk about programmers who get into this, who are more of an analytics, not an analytics person, but some engineers who are embedding AI, they're very, very, very uncomfortable with probabilistic thinking. us in analytics, that's what we do for a living, right? This doesn't bother me at all that it was 96% certain of one answer and it still had some non-zero probability on others. That's the world we live in. The general population doesn't necessarily think this way, and this is one of the things that on the software side people struggle with. You're used to programming. If A, then B. There's a framework, there's a logic, and it might be very complicated, but it would have been rules. Here you end up with these probabilities, and even if it's incredibly sure, it's never going to be 100% sure, and there will always be other answers that could be there. So at the end of the day, it's back to why it's analytics. All of these things end up putting out some set of answers with weighted probabilities of being correct. So 89% it's a cat, but it's also possibly it could be a ferret, right? Or it might be Maxwell Silverhammer, but it could still be Frank Sinatra. And so I hit on this. One of the huge, or not so huge, depending on what you need, issues with AI is that it's opaque, right? So if I were to build a classic regression model or a decision tree of some sort, or even a lot of the standard algorithms, you can actually look at what's under the hood and why did I get the answer that I got. Not true with a lot of these AI routines. In fact, they're by design somewhat opaque. Now, in some cases, we don't care. So if it's Facebook and you just want an image tag that it's your friend or not, as long as it's accurate, pretty much, you're fine. You don't care how it gets to the answer, nor does Facebook. But when you get into something like credit scoring, and I'm going to make a loan or not make a loan, or I'm going to approve an insurance rate or not approve an insurance rate, there's a lot of both legal issues as well as ethical issues around what data is used and in what way. And in those cases, it's still not really possible to use AI because of the opaqueness and the fact that you can't show exactly how it got there, and that means then that you actually can't use it. So what you have to decide as you start to experiment today is, are you dealing with a problem where not knowing how it got to the answer matters or not? If it doesn't matter, have at it, right? If it does matter, then you're going to have to tread a little more cautiously today. But as with anything, there is progress being made. So how do you basically reverse engineer what's happening in a model? And this is a fascinating concept. It's local interpretable model agnostic explanations, called LIME. You can look this up. But here's what's really cool. If you look at this picture over here of this frog, what it basically does, it will randomly change the image, effectively gray out parts of the image, and run it through the scoring routine with just subsets of the image, and see what answers come out, what the probability it's a frog. And this gets into, after you've done the millions and millions of iterations to get the tree frog scoring algorithm, now you have to do millions and millions of iterations of randomly changing a given image to identify what are the core facets of that image that's actually driving the tree frog probability. And you can then get down to, on the right, it looks like it's sort of the mouth and eye area are some of the biggest contributors. The cool thing about this methodology is that it's model agnostic. So when you look at any type of model, you could reverse engineer. So if, for example, someone at an insurance website had some kind of scoring routine, and if they weren't going to have some check and balance to stop me, I could just go and put in millions of requests, slightly changing the input data of my age, my income, my number of accidents, et cetera, and look at whether I got approved or not. And over time, I could kind of reverse engineer what the primary factors were driving that decision. And so this is an example of something that it doesn't actually directly relate to AI, but is perfect for a scenario like AI where you have these images. There's deeper variations, too, where they're saying, like, if you have, whoops, I think I hit the back ones. There we go. You can do it stepwise. So identifying a zebra, stripes is a huge indicator. So if first you can identify, yeah, there's a lot of stripes, which gives a high probability of a zebra, you sort of lock that in, and then you go to the secondary things. Now to confirm if it's a zebra or not, we've got to see a head and 4 legs and a tail, et cetera. But you can kind of step through it. It's almost logically like a decision tree type concept, but with the AI, where you're looking for key traits, and once you lock one in, what are these stripes possibly associated with might narrow it down to 5 or 10 things outside of a zebra, and as you find more and more of them, then you narrow in. So all of this requires tagging, and so this is one of the most interesting things, is if you go to an AI show, you're going to find there are entire companies now, and there's entire open source projects as well where people are volunteering to do this, just to tag data to feed into algorithms. So if you're going to identify and train things, well, you got to know what a tail is. You have to know what stripes are. You have to know what eyes are. And it gets back to any given process can be really good at one thing. If you have a process that can say there's definitely stripes and there's definitely a tail and there's definitely legs, and you start to recognize all the traits, that can help you then get to the point that it's a cat. So there's an open source image project. I think that it's something up to 10 million images with 22,000 tags that people have gone out and done. Because again, to build the algorithm, you have to have the cases of what is and isn't whatever you need and provide those traits. There's a company that is in the autonomous vehicle space. All they do is generate clean, I'll put clean in quotes, as clean as possible, data to train autonomous vehicle algorithms. And what they have is they basically have video of going down the street. And they have people meticulously tag sidewalk, tree, stop sign, pedestrian, et cetera. And you need to have all of that then in order to have the real life data for the models to build off of. So one of the limits of some of this is you've got to target problems where your success, whether this was good or not, is near to the action that you take. So back to how it starts done. When you teach AI to play Pong, and you can go out, there's some awesome articles and videos on this topic. But literally, it has no idea there's a ball or a paddle or it's even Pong. It's actually looking at pixels. It sees, whatever it is in Atari, 200 by 200 pixels. And then it sees a series of 200 by 200 pixels that slightly change. So as the ball moves, the next frame it sees might be shifted down a little. And what it has to decide is action 1 or 2. Action 1 might equate to up, and 2 to down. Again, it doesn't necessarily have any concept of that, but it says, I'm going to try 1 randomly. And then it'll say if that ended up being a good or bad move based on that set or recent pattern of pixels. And what will happen over time, again, it'll luck into knowing what to do. So if you watch an AI algorithm playing Pong, a person's going to kind of go up. It sees the ball's coming this way. It's just you're going to go up like this. The AI is going to be doing this the whole time. As it basically still has a ton of randomness around a slight bias towards the right spot as it sees a trend. Oh, the pixels are kind of moving this way. I need to pick option 1. And so when it's a relatively simple game, you can train it pretty well. And in fact, AI can beat people at some of the simpler Atari games. Here's a game called Montezuma's Revenge. The problem here is to win, you start and you're this guy on the middle. You have to climb down the ladder, go down to the bottom, dodging the skull, climb up and get the key, go back down, dodge the skull, and work your way out. There are so many steps between where you start and where you get a, quote, success that randomly attempting one move after another it's going to so infrequently ever actually luck into the right answer, you can't train the model. It'll do horrible at this type of game. Now, over time, as processing gets faster and faster, maybe we can get to trillions or quadrillions of trials, you'll have enough cases where you literally lucked into the 500 consecutive correct moves to actually win this game. But today, again, it's the constraint is something that's a little closer to action. And if you go out, anyone who's ever played video games will find some of the articles and videos you find in this space really, really fascinating. So one of the things as well, this ties to if you put this together, learning complex tasks, even for people. If you learn individual, simpler ones, it gets easier. So when you teach a kid to play baseball, they start out, they have a ball stationary on a tee, and they kind of learn just how to even swing at it and hit it. And then you get to where there's a coach kind of lobbing a ball as perfectly as possible time and again. And eventually you start really throwing the ball. If you were to throw me a ball right now, I'd be able to just go up and catch it. Now ask me to explain, well, Bill, exactly how did you catch that ball? Why did you have your hand exactly like this and not exactly like that, right? And why did you kind of stop when the ball was 3 feet away and not when it's 2 feet away? I would have actually no idea. And so in a way, when people say, well, that's a big flaw or that's a problem with AI, some of the fact that you can't parse out what it's doing, well, that's what we do all the time. Half of what we do every day, we can't actually explain precisely why we do it. We can give you a general description. Well, yeah, I know I got to sort of get under the ball. I got to get my hands positioned and catch it. But I couldn't tell you why my hands are this way or this way and how I make that decision because it's sort of automated. And so in this context, a little game like Lunar Lander, if you just say, play Lunar Lander, where you can go left, right, you can thrust up, and you have to land not too fast on one little pad down in the bottom, what is that, the bottom right corner, that little flat spot. That's a very difficult game to train if you just have it go starting there. But if you train it, here's how you kind of move left and right to try and get over near a flat spot. If you train it also separately, here's how to thrust to keep your speed in check. And you have another algorithm that kind of tries to identify correctly where the safest spot to land is. Once it knows those three things, you can put them together, and it'll learn much faster how to then play the game. So you can also think through, what is the overall task I need to complete, and how can I break down into some of the subcomponents or subtasks that might be easier to train. Once those are trained, I train on top of the initial. And in the near term, and probably long term, it's going to augment more than replace humans. So when we talk about AI and what's it going to do, if you think about it, a lot of what we do as analysts, we've complained for years about how much time we spend just through doing a lot of grunt work and monitoring of processes. If I could have some automated routines that will do a whole lot of that grunt work for me, I could solve more problems. So we're already getting to the point where if I have a data set and I want to predict something, I can pretty cost effectively just, there's tools out there that'll do this, run every algorithm that theoretically fits this data structure for this type of prediction. Try them all and try every variation of them all and see which one works. Try a random forest, try a deep learning algorithm, try a regression, try anything that you want, and you can effectively do it. So why spend time sitting and worrying about exactly which options to try when you can effectively try all of them? But while that algorithm is trying all of the options on problem 1, and I'm not having to worry about that, I could go to problem 2 and maybe even problem 3 and kick off some similar things. So in the near term, it really gives an opportunity to free up people, I believe, to do the higher value added things and to get a lot more done and solve a lot more problems. So an analyst, rather than having, I don't think it leads to firing of analytical talent. I think the analytical talent, you'll be adding so much more value that you've got yourself even more job security. And if you're solving that many more problems, you might even still end up expanding the group further because of that high level of productivity. There's a McKinsey study you can look up that looked at this problem specifically, and they did something interesting. They did not look at, can your job be replaced? Because they looked at, rightly, jobs are made up of tasks or activities, as they termed it. And there are some activities that are easy to replace and others that are not so easy to replace. So having a little screw get inserted on an assembly line, that's a pretty easy task to automate. Deciding which of many types of screws and manufacturers might be the best one to actually feed into that process, not so easy to automate. That takes somebody with that experience. And what they found was that there are jobs, as we all would expect, that are very highly automatable today. So if you're a cashier at a fast food restaurant, pretty easy to automate a lot of that job today. And even as we get into near future, even common questions that you might have of that cashier, Siri or Alexa style bots will be able to handle the majority of those, and you'll probably have a need for one supervisor to answer the really more difficult questions. But even CEOs had like 30% of their tasks automatable. And so the key here would be, if you look at your job, look at what tasks do you have that can be automated and what can't be, and obviously try and guide your job and your skill set towards those things that'll be more difficult. And this isn't totally correlated with income. CEOs, 30% automatable, but they mentioned like landscaper, very low paid, low education job. Hardly any of landscaping work could be automated anytime soon, because you're talking about going out and digging holes and picking weeds and putting in new plants. That job's completely safe, even as other jobs that pay similarly and require similarly not much education can be automated. And so if you're going to succeed with analytics, what you need to do then is what I call embrace analytic athleticism. And so this concept's very easy. If you go to a sports field and watch some kids play, whether it's basketball, soccer, or anything else. So we put some of you guys out in the little garden out there and had you try and play a quick game. We can pretty much tell who's got the skills and who doesn't within a few minutes. I mean, even unathletic people who have never played a sport can look at the game and say, this person's good, this person isn't very good. Now you can coach people. You can get a world-class coach to coach the entire 5th grade class at the local elementary school in basketball all year. And you will maximize each of their talents to the extent possible in the time frame. But the people who aren't very athletic are still not going to be very good basketball players. And similarly, those who are really good are going to be naturally pretty good. And they could probably run out on a soccer field and do decently well, or run into a volleyball court. And so the point is, AI is analytics. Its purpose, the thought process behind it to identify the right problems and implement it correctly, requires analytic thinking. When you have people who understand analytics, who can have that thought process, the idea that somehow they couldn't expand that to also succeed within AI, which is effectively a slightly different version of the game, is silly. I think it's absolutely possible, and you absolutely can take who you have and expand and succeed with AI. It really comes down to evolving like a medical practice. So if you go back 200 years, you would have had, if you're lucky, a town doctor. And that town doctor would have treated your broken bone, would have treated your flu, would have done surgery on you. And that's pretty horrifying today, the thought that one person would do all that, because we know how difficult that range of things is. But back then, medicine wasn't very advanced, and that person could give you a reasonable approximation of the best care in all of those areas of the day, which spoke to the low level of sophistication of medicine. Today now, of course, we have not just a doctor, we still have general practitioners, but then we'll have a cancer doctor. But not just cancer, a pediatric cancer doctor. But not just pediatric cancer, pediatric brain cancer doctor. The point is, as medicine has become more sophisticated, we still need a generalist that you still go to kind of help triage and identify the general space of the problem, but then you go to a specialist to really solve the problem. Same thing with analytics. When I first started in analytics, it was much closer to the 200 years ago than today. You'd hire a smart stats, operations research, or econometrics person, and they would do a good approximation of any of the analytics companies needed, because there wasn't that huge of a range of analytic types, methods. There was only 1 or 2 packages you could even do analytics with, mostly on a mainframe. Today, like a medical practice, you go to these office buildings today, they have not just general practitioners, they have GI people and allergy people, et cetera. You're going to have to build your team where you're going to have some general analytics folks that can help identify the problems and scope what's done, but then you're going to have your marketing mix specialist. You'll have an AI specialist. You'll have a tech specialist. All of them together will make your team successful. So where we're at with AI today is that the potential is being proven left and right. There's a lot of case studies of successful prototypes being built that prove something. The gap today is that a lot of actual realized results have not yet occurred. This is in no way reflective of the fact that they can't be in time. It's that they've proven it, they haven't rolled it out. Let me give you an example. There are processes today, both AI and general analytics processes, that can identify who's at risk of certain diseases and or who needs certain treatments in medicine. The problem is, even as those algorithms are shown mathematically to work, you can't actually deploy them today. There's not a mechanism. They haven't actually had it where the doctor gets a note that says, our algorithms have determined that this person has this, this, and this. You just need to kind of do a quick check and confirm that. And certainly the algorithms can't lead to a diagnosis and a treatment and a dispensing of medicine. So in all of the various areas that it's being proven, you would get back to having to operationalize. Proving that it works and proving there's dollar value, you still have to go that extra time to figure out, how do I actually scale and deploy this thing at an enterprise level to make it just operate on an ongoing basis. It's starting to happen, and it will happen more and more, of course, as we go forward. But this is one thing. As you search case studies, you'll find a lot of case studies of a prototype that's proven that you go, wow, that has huge money at the end of it. You just won't have actually seen the money achieved yet in most cases. And so because of all of this hype today, I would say your analytics strategy as an organization, and as even the sub-organizations that are here, has to include AI. Now, that doesn't mean, when I say this, that you all have to be running to AI and starting next month, regardless of whether it makes sense and you've identified good use cases. You don't want to make the same mistake people did with big data 6 years ago, where everyone just went out and started buying systems and loading data to, quote, do big data. What I mean is, it's a hot enough topic that you will be asked from the executives, well, what are you doing for AI? And you have to at least be able to say, we're looking at it, we evaluated it, given our priorities for the coming year. It's not going to be a component of this year's plan, but we took a look and we're going to re-examine it next year. I think that at minimum is going to have to be there, because if you're not accounting for it, people will think that you're somehow missing something. And back to it is coming. This is going to transform most every industry and market, just as analytics has, right? Because this is an expansion of analytics. It's some new analytics that have a lot of power that are going to be operationalized. And the money speaks. There's, I think last year, the estimate was something between like $30 and $40 billion was put into AI technologies and algorithms and testing. And interestingly, there is a lot of VC money in there, but over half of it was from the tech giants investing on their own behalf. So even if some of their VC arms were investing, they're only investing in things they think they can, they're going to be able to pull back in. And so this is a difference. There have been times in the past, some areas with VC money, it's been largely VC funded stuff initially till some things are proven, and then other companies either jump on board and or make acquisitions. The big guys are putting big money behind this today. And then back to how they're even open sourcing a lot, that benefits everybody, right? Everything's getting easier and more friendly to use. And so the key here will be, at some point, I'm sure everyone in this room is going to end up just as you code in Python or R or SAS, and you either do marketing mix models or propensity models. Some of you or others on your team are absolutely going to be doing some deep learning, some natural language processing, et cetera. It's a matter of exactly when will that happen and how much. And I'm sure, with the diversity of business units at Cox, there will be some that get into it much faster, than others. In fact, we were talking at breakfast even, when you're looking at automobiles for an auction even, taking some pictures, and if you could have routines that know how to look and identify anything that could be sort of a scratch or a dent or an imperfection, and like at TSA, when you go through that scanner and it highlights the spot and they know exactly where to pat, if your person assessing the vehicle can get a quick thing that just highlights 3 or 4 spots they have to double check on the algorithm, that could save a lot of money. So the key takeaways, and we'll have a couple minutes for some questions. It's the processing power, the data availability, and the algorithms come together to really make AI possible and real today, where in the past it was theoretically real but not in practice real. It wasn't real in an actual business application sense. You cannot mistake the difference between generalized and specific intelligence. It's very specific intelligence for any given AI process. You can train it to know many specific things that add up to some very impressive total knowledge, but you're always starting from random with a very specific training task. You are going to have to get some new technology, both in terms of tools, data. You're going to have to learn this, this expertise and bring it in-house over time. I think, again, this is just the same thing that companies like you have done for years. You evolve your systems, you evolve your practices, you evolve your data. There are a lot of legal and ethical issues. If we had longer, I could have gone 10 or 15 minutes on this alone. But we do have to resolve this. What is appropriate use in medicine for AI in terms of what we'll let it do and won't let it do, and then who's liable if the algorithm makes a mistake. There's lots to think through here. That potential value far exceeds realized results today. That's what I just went through. That's not to say those results won't be there. It's just that today it's early enough that there's much more proven in theory than fully rolled out, operationalized, and driving dollars every day. And you definitely need to get this into your strategy and start to think about it and how you'll address it over time. So before I take questions, you guys will get a PDF of this. Again, I work for International Institute for Analytics, founded by Tom Davenport, who wrote Compete on Analytics about 10 years ago. And we're a research and advisory firm. We focus on helping companies improve their analytic performance through research, peer-to-peer interaction. We have capability assessments, strategic advisory work, et cetera. But you can find more on our website, or this will be in the handout. So with that, I guess I'll open it for any questions. I see one in the very back over there. Oh, and I think they said they're recording this, so make sure you get the mic, because it won't stream if you don't have the mic.
You talked about the algorithms and some of the things requiring a lot of computing power, and so they're not totally practical right now. Can you talk a little bit about endowing some of those things with heuristics so that we could basically speed some things up without maybe getting absolutely foolproof solutions?
Yeah, that's a great question. And in fact, that's why I'm excited about the potential today. So back to it, that friend of mine who introduced me to deep learning I don't even know, it was somewhere between 3 and 5 years ago. It wasn't that long ago, and he was describing what they were doing and how it was working. And what he told me was that out west in Silicon Valley, they were paying people 7 figures if you knew how to do this stuff at the time, because it was so specialized. So this wasn't like 7 figures to be the senior vice president of AI strategy. We're talking 7 figures to be the guy day to day just coding the heck out of the algorithm. So what's really changing, back to your heuristics now, the algorithms are starting to be open source, but then people are putting things on top. So if you want to do image recognition now, you can go out. You don't necessarily have to build the whole framework for recognizing images. You can kind of download or rent on the cloud a pretty well set up thing where you basically say, here are the images that have what I want to identify. Here's a bunch of other images. Now go. And it kind of automates. And to your point, if you really know what you're doing, you probably could tune it to do better than that off-the-shelf thing. But the off-the-shelf thing is really good and really fast and really inexpensive. And for a starting point to prove out that your idea is going to work, absolutely go there. And then if you say, man, this has a lot of money, now I'll invest time to try and add additional power on top of the free/cheap prototype. But I think that's absolutely this idea of widgets permeating all of analytics today, where I think we're going to be building less as much as we'll chain together things that have been built. And when we do build some new process, whether it's to clean a certain type of data, to run a type of model, we'll package it up. And you can already see in the modern, what I call the modern workflow-based analytics tool sets out there, it's exactly what happens. You're connecting, widget 1 to widget 2 to widget 3, and you have what's a very complicated analytic process, but that's actually pretty easy to see visually and pretty easy to lay out, and you're avoiding having to custom code or even necessarily, in some cases, understand the code underneath it, as long as you're appropriately educated on what the inputs need to be and how the outputs are to be used. Let's see one in the...
So, admittedly, what you just said, I still need to process some of that. But as you see things like FPGAs starting to come into the market, do you think that's going to pose a problem to a lot of people's cloud ambitions of going to somewhat specific technologies that are going to handle these high rates of AI processing?
Well, I mean, I guess, so, cloud's evolving very rapidly. One thing I always point out is you can't mistake the cloud as an architecture or a manner of allocating and accessing a set of systems and public cloud. A lot of people think cloud is only the public cloud. So there's private clouds, which means you could host your own environment that is set up exactly in a cloud architecture, exactly the same benefits and everything of a public cloud, only you own and manage it. And a lot of companies are doing that. So there's a mix of the public and private clouds, but the advantages of what's happening now is you can go out and experiment with any number of tools or types of, which GPU is best. I can actually go out and experiment with 10 types of GPU processors on some of these clouds today, test them for what I need, and do it. Now, if I might say, if I have a lot of sensitive data that for whatever reason we're not going to put out in the cloud, okay, great, then I can bring in and set up a similar environment internally. So again, I think even at the most conservative / worst case of cloud adoption for ongoing sensitive data in production, I still think it's going to have huge benefits on this exploration and identification of what's going to work and what's not going to work, to the extent that you can put out some sample data, and you might have to mask it if you have heavy legal regulation. But there's a ton of benefits. And I know at my last company, we had a guy, we wanted to, our R&D department was being really slow with trying to integrate GPUs. I literally had one of the guys on one of my teams, he went out and bought a GPU for like $1,000 and connected it to his laptop and just saw what did it take for him to actually push processing there from the system. Again, it wasn't that what he was doing was going to be something scalable we'd recommend everybody do, but we were able to go back to R&D and say, look, I just had a guy with a laptop and $1,000 prove that it's not a ton of engineering work here. If you can just automate a little connector that does sort of what he did, we could have access to GPUs today, and it made progress. I think I see one in the middle back. Oh, one over there too? Oh, sorry. And how many do we have time for? These two? Okay.
Testing? Okay.
Yeah.
Is there a specific tool or popular tools that are being used to do this deep learning or AI? that you know of?
Yeah, so I mean, there's a wide range. I had the logos on one of the early slides. So for deep learning, like the image case, Google's done a ton of work, and they have a product called TensorFlow. If you go out, you can go out to various sites. I mean, there's sites ranging from, KD Nuggets. You can just go search out, AI tool sets or AI open source projects, and you'll get a good range. There's some that are based more on text analytics and figuring out text, because obviously that's a whole subspecialty in and of itself. There's some that focus a little more on images, or some that are more broad. But the beauty of it is, again, you can go out and search around, and I'll bet you within a half hour you'll have enough to keep you busy doing some research for a while. And as you learn the terminologies and so forth, you'll start to have a little bit of a feel for how all these fit. And in my personal opinion today, while it's maturing, there's not a single best answer for every problem or every person. Today, there's still going to be different of these projects would make sense for you on your specific problem. You just have to dig in a little, figure that out. I think we had the last one over there.
So, are you hearing anything about AI and quantum computing, or is it too early in the quantum computing life cycle?
It's a good one. So quantum computing is, I think it's earlier stage. I mean, there have been proven prototypes of a quantum computer working, but it's very expensive, very small number of qubits, as they call them, and not yet scalable. I have heard of people attempting to merge the two. I think what the catch is, in the short term, I think the quantum computing isn't let's say, widely commercially at a viable price point available. In the long term, maybe long term defined at least 5 years, maybe when you get out to 10. And actually, if we could start to buy a quantum computer, I think it'll be similar to how a GPU can accelerate certain types of processing. Those quantum computers, their ability to effectively it uses quantum physics, right? It can sort of experiment with every possible answer simultaneously somehow. It's very bizarre. If you go read, you can read in, like, Discover Magazine's had some series on that over time. So I think these two things will necessarily bang heads eventually. I just think today it's not a, I always come up, does it matter for your business today in the next 2 years, would you worry about that? My answer would be no. From an intellectual curiosity, could you follow on that and keep up on the trend? Absolutely. So I guess thank you.